So what shall we do then? Make ourselves harder, better, faster, stronger, eyes on elbows, all very interesting, but there is one particular evolutionary bad boy we might rewire that's so fundamental to the human condition we barely even notice it's there. And its name is misery. We are not designed for sustained happiness or optimism. Natural selection had very little interest in our mental welfare. Survival was key. As a result, it seems most of us, regardless of geography or social standing, have a hedonic set point. That is, something good might happen and you'll feel good for a while, something bad might happen and you'll feel bad for a while, but eventually you will probably return to your baseline, which appears to be set out of your control, partly genetically. For some individuals, this set point is rather high. For the rest of us though, not so much. And that's ignoring all the other pitfalls of Brain 1.0, including age-related dementia, self-loathing, a tendency towards addiction, low boredom thresholds, and everything else we didn't ask for, genetically speaking. These nasties have haunted us for millennia, and they seem to form part of what we've lovingly come to know as the human condition, which for many of us is just shorthand for stuff we can't change and it's natural and have a cup of tea and get on with it. But if we crack the ability to send these evolutionary dishes back to the kitchen to engineer ourselves happier or more content, shall we give it a whirl or not? After all, we've got such a great track record with limiting the few godlike powers we already have. If we do gain mastery over our own genetics, how far shall we go with this one? And how the hell will we know when to stop? Now, luckily, genetic engineering is really simple and there are no risks, and genetic engineering is really simple. You see, there's a single gene for everything, a cleverness gene, a tallness gene, a really good looking gene, and they can just be turned on and off without affecting anything else, and there being no bad consequences. And genetic engineering is really simple. There's definitely no risk of making horrific alterations to the human genome that only become apparent generations later. There's no risk of nasty folks creating engineered drug-resistant pandemics that are virtually impossible to eradicate. There's certainly no risk of a group of us getting hold of the technology and creating an entirely separate genus of humans we can't possibly compete with in any aspect whatsoever. Genetic engineering is unbelievably complicated, and it's not hard to see why people are extremely cautious. We are currently children who have just about learned the genetic alphabet, but we can't read yet. So what can the new genetic technologies actually do? Well, in each of our cells is DNA. DNA is packed within chromosomes. Chromosomes are extremely long strings of DNA composed of 4 bases, A, T, C, and G. Lengths of these are called genes, and proteins are built inside your body as a result of genes. If you like, genes are genetic verbs telling proteins what to do. We've been genetic engineers for centuries now, breeding species for the sake of characteristics we want in doggies, for example. Small ones, big ones, the bestest ones, but even that goes wrong sometimes. Many species of doggies are adorable, but possess nasty inherited traits like hip dysplasia and epilepsy thanks to us, and this is just simple genetic engineering we haven't managed to get right yet. So far we've been using hammer methods, but now we may be holding a scalpel method called CRISPR, and it works, roughly, briefly, like so. Some bacteria can store an intruder's DNA in their own DNA in a genetic library called CRISPR, or clustered regularly interspaced short palindromic repeats, and using that as a template, using an enzyme called Cas9, it can kick ass if the intruder comes around again. Researchers have hijacked this trick and have begun to use it to snip out targeted sections of DNA in other organisms. Considering there are thousands of diseases caused by a mistake of just one letter, not too much alteration might be needed to fix all sorts of nasties latent in human DNA. This isn't a question of if we start radically altering human biology, it's when, because even if most of us condemn the technology, it's not as if other researchers won't pursue it. They've started already. Obviously, hopefully, we'll begin with eliminating genetic disorders, but surely there will come a point, perhaps this century, when we get a little bit more experimental. And the question is, what happens then? Well, we might be children at the moment, but we know enough to notice that certain genes, when they're present, accompany specific traits. DEC2, for example, is a genetic mutation allowing some of the humans who have it to survive on around 6 hours sleep a night. But genetics is rarely one gene equals one trait. There isn't one intelligence gene, and there probably isn't going to be a single depression or makes hummus delicious gene either. What we know from twin studies though is that somehow very specific traits can be inherited. There may not be a single good at violin gene, but there might be a bunch of genes that go into being good at the violin that one might inherit from their parents, like decent hand-eye coordination and pitch sensitivity. But in any case, genetics is not a switchboard. Happy on, sad off, bada bing, let's go for a pint. It is an interconnected tapestry in which some traits traits are caused by loads of genes, potentially thousands, and small alterations could have horrific consequences. There's nothing prudish about being cautious when it comes to a cheeky bit of the old playing God.